Hello. Welcome, everyone. My name is Vipul Gupta, and I'm a principal engineer with the AWS KMS team. I'd like to welcome you all to this session. Thank you for coming. All of you must be really good at treasure hunting because this session wasn't even on the session catalog until Tuesday because our feature wasn't announced until Tuesday. So the fact that you still found us, congratulations. So I've been with AWS KMS for about 3 years now, and half of which was spent on this project. So it's been a long journey, but it's been an exciting journey, and it's really wonderful to see the feature being announced and so much interest from customers. So I will hand this over to Jeremy, and I'll come back for a demo later on. And if you see me sitting here quietly with my eyes closed, I'm just praying to the demo gods, because you know how that goes. So.
Thanks, Vipul. We're here today launching the External Key Store, a new capability in KMS that allows you to use external encryption keys integrated with KMS. It's part of a broader digital sovereignty strategy that we launched this week. We put out a new blog on Monday. I would encourage you to read it. It highlights some of our pillars of sovereign by design, including the customer is in control of their data, the customer is in control of the locations of that data, an encrypt everywhere strategy, of which this new feature, allowing you to encrypt outside of the cloud, is an integral part of what we think a sovereign solution addresses. The fourth pillar is around resiliency, ensuring that your cloud can never be brought down or maliciously taken down. Well, we're going to jump into XKS in the next half hour, and then Vipul's going to do a real-world demo, which is kind of cool. Real packets will move from different data centers to different data centers and complete encryption operations in the standard flow that we're going to be talking about today. To get there, we're going to take a little bit of a peek into why we built this feature, what we built to support it, the proxy, some of the new terminology we'll be talking about. We're also essentially extending capabilities we've already had. So for those in the audience that are familiar with the custom key store, this will feel very familiar to you. In fact, a lot of the same setup, a lot of the same capabilities, a lot of the same design is used here. We're borrowing scaffolding from the custom key store, which allows KMS to connect to Cloud HSM, and use it to allow KMS to connect outside of the cloud. We'll get there in a moment. We'll talk a little bit about usability, the sort of parameters of where you can use this inside AWS for both client-side applications and how to integrate it with integrated services that talk to KMS. And if Vipul is blessed with the right demo gods, we'll show a live real-time demo. So why external keys? XKS is for customers who want to protect their data with encryption keys stored outside of AWS. This is coming from some different drivers and forces out in the market, some of which are regulatory and some of which have legal frameworks around them in other countries that encourage different levels of key control, and some of that language encourages the customer to retain control of their keys. So we built this listening to customers that asked for a way for KMS to use external keys. And as I mentioned, it's built on top of a custom key store, which is kind of nice for us, because we've been in the business in KMS of talking to another HSM and having to figure out how to talk to another HSM for 4 years. So in a way, this isn't new to us. We have a lot of experience, and we have a lot of large-scale production customers using our custom key store, and we were able to learn from that learning and how we designed XKS. But before we get to the specifics of XKS, let's just talk about the world today. Just maybe the world on Monday before we launched and went live. In general, in KMS, before external keys, there were 3 places to make keys and 2 places to protect them. The most standard way to create a KMS key is inside KMS. That's the red box in the middle. You ask KMS to create a key. KMS creates that key and stores it in our fleet of HSMs. That is the most common way customers use KMS. Of our 30 million keys, in the order of 29 million use that pattern today. You can also bring your own key material. That's called sometimes BYOK. And in that flow, you are creating your own key material and using an import API to bring that key material seed into a KMS key. Once imported, a KMS imported key more or less acts and feels and looks like a KMS key. It is protected by the same fleet of HSMs. It has the same policies, the same tagging support, the same audit trail, the same service integration model, the same familiarity with ARNs and everything else, aliases. So an imported key is fairly close to a KMS key. There's a couple salient differences. You own the key material. You are responsible for the durability of that key. The third place you can make a key, and the second place you can store a key, is through the custom key store. The custom key store is for customers that want to replace our fleet of multi-tenanted HSMs with a customer-owned, customer-operated, customer sort of isolated HSM. With Cloud HSM, you buy it, you operate it. AWS has no operator access to that box. You are controlling the data plane of key operations to the Cloud HSM. And we are taking that framework and now launching the custom key store for the external key store. In this case, you create a key in your external HSM, and then you use a KMS key as a pointer to it. And as we get into this more, we'll be using the word proxy a lot. I think the right way to think about KMS is it becomes a smart proxy. It takes requests from services or client applications, and it translates them and proxies them out to your key manager or your external HSM located in your cloud, your SaaS, your third-party systems integrator, your data center. It is outside of AWS technical infrastructure. And that's really the meaningful, if you leave with only one understanding of today, external keys keep key material in your possession in your building. What are some of the technical highlights of this feature? The way we use this is we replace our root of trust with yours. All of the key material of these KMS keys are entirely in your external key manager. The top of the key chain, the top of the hierarchy, becomes your key manager, your HSM in your building. That also gives you some enhanced visibility and control, because now you're seeing requests over the public internet into your building, into your SaaS. You have external visibility, external control over our requests on that key. One of our design goals, now that we have well over 100 services integrated with KMS, the likes of Lambda, Kubernetes, S3, RDS, Mongo, Clydesdale, WorkDocs, Secrets Manager, Aurora. It would almost be easier for me to name a service that's not integrated with KMS that is. We didn't want to have them all do work for the external key store. So in every one of our integrated services, XKS is essentially supported out the door, and it's supported transparently out the door. You simply use the KMS key picker, and you pick an external key, and your work is pretty much done in S3 or Lambda or Secrets Manager and so forth. One of the other nice sort of design goals that we met is that you can have very granular decision-making over when to use an external key. Because the decision is made on an individual key basis, you can choose to go to an external key store by role, by region, by service type, by data classification, or any sort of tuple of those. It could be project tag, plus these users, plus this service, in this region. Please use an external key. And that individual atomicity of deciding on a key basis gives you that level of flexibility. One thing to note about the sort of key management of this key is KMS is sort of a proxy of it. It has a pointer to it, but it's not the owner of this key. You are the owner of this key. And so we made a technical decision that KMS shouldn't be involved in the life cycle of that key. So when you set up XKS, you will set up the life cycle of that key on your own. KMS has no APIs, no control path APIs to manage the state of that key. We can't disable that key. We can't ask a third-party system to create that key. All of that life cycle, and I think this is pretty logical, all of that life cycle of creation, rotation, replication, deletion, disablement will all occur in your key manager outside of our control. Ultimately, this sort of serves as a kill switch. If you turn off your external key store, AWS data using that key becomes unreadable. KMS has no long-term caching of the response and no access to that key material and can never get that key material back inside the cloud without another XKS request to a key that's been re-enabled again by you. I'm going to use some terminology today, and so is Vipul. Just a quick cheat sheet on that. The custom key store is this construct that allows KMS to replace our fleet of HSMs with another HSM system somewhere else. Either Cloud HSM, which launched in November of 2018, or the external key store, which is a custom key store backed by an external key manager. And that gets us to our second bullet. We struggled with this one a little because some customers think of this as an HSM, and that's what we want to connect to. And some vendors build other kinds of key management systems. And so we needed one word to kind of wrap up software services, virtual HSMs, physical HSMs. And so in all of those places, we're going to be referring to those things as external key managers. But in essence, they are things capable of answering our XKS phone call. And our XKS phone call is pretty straightforward. It's please encrypt something, please decrypt something. And so we'll get into that protocol flow in a moment, but that's essentially what an external key manager does. Last but not least, we need this proxy component, really the middleware of this communication, and we needed it to be multi-vendor. We did not want to build dedicated clients to dedicated third-party products. And so we published a specification. We worked with the industry's largest key managers, and we're really proud to be announcing great support for the external key store today. And we're going to talk about some of that vendor support coming up. Thanks to all of them, Thales, Entrust, HashiCorp, Fortanix, fantastic work, fantastic engagement to get us here today. We wouldn't be here today without those vendors working with us in order to get the specification defined and in order to be able to receive those requests going out to them. So what does this look like under the hood? We've got all of our services on the left side, and I ran out of room on this diagram, but also on the left side, we would put client-side crypto applications. So for those of you using the ESDK, or the Dynamo Database Encryption Client, or the S3 Encryption Client, all of those work with external key store as well. But client-side, or what we refer to as server-side encryption, which is the AWS services that support the data protection pattern, and essentially, starting in 2020, we set a security requirement that any service that touches customer data must offer a data protection pattern to KMS. That's why that number is well over 100 and growing. I think we launched 15 new services this week with KMS integration in them. But all those services will communicate to KMS essentially the same way they do today, with APIs like generate data key and decrypt and list keys and grants, and all of those capabilities will be identical for XKS keys. KMS will be smart enough on an XKS key to recognize it doesn't own the key material. And it's going to need an external key store proxy to answer this question. So KMS will translate front-end APIs to the XKS proxy. The XKS proxy will communicate to your vendor of choice, or you could build your own XKS proxy. We've actually gone and published to GitHub the specification, client tools, reference Rust implementation tools. So if you wanted to take a look at that, there's a GitHub project in our What's New post and in our blog post with more details on that. But essentially in this diagram, we're depicting a connection from KMS to your VPC. And in that VPC, you are managing things like firewalling and load balancing, and then directing the proxy to talk out of the cloud. There's a different way to wire up XKS. Didn't have room on one slide to try to do too much. We think this is the more standard pattern, is that you'll tie KMS to your VPC and then route out that way. But there is also support in XKS for what we call direct public IP connections. So if you had a public IP address, you can route through Direct Connect or your own VPN technologies, you can connect that to the XKS proxy as well. So two ways to connect. This way depicted here is the VPC pathway. We expect most customers will prefer this pathway. Let's go into a little more detail. I think I covered this one already. You simply select an XKS key, and the data protection in that service will then route out to your external key manager. We're also not really changing too much in KMS. The front-end APIs that you might rely on in your client applications or the services call are all identical. The work is really in KMS to be smart enough to say, oh, this is an encrypt request that uses XKS. I'll need to translate this into the XKS proxy. And this is really the last point of KMS technology, really the last point of Amazon sort of operator software technology. The XKS proxy is our VPC endpoint from KMS, and it connects to your system. And this is the place where we start to think about HA, clustering, reliability, resiliency, latency, and everything else. You own everything from this point on in terms of network pings, pass that VPC out to the internet, as well as clustering and multi-region failover and anything else you want to build. We've built a well-defined client that can connect to your cluster of key managers. So for those running very large workloads, very important critical workloads with mandatory high availability, supreme fault tolerance, you would want to think about multi-location, multi-clustering of this connection leaving the KMS interface. And kind of in furtherance of that, you own the round-trip time. So we aren't going to own the turnaround time from your XKS solution, and we have some guidance as to how to design that with some proximity to our geographies. For example, if you were running XKS from Singapore to a data center in Dublin, you would be frustrated because the time it would take you to ask for that key request and have it come back, we would essentially time out before we could ever get the answer. And so we have to be aware of some latency boundaries, some latency budgets here, and we've got some guidance in our documentation that talks about some best practices for how to set this up. So what is that proxy? Let's go in one more level. This is the lowest level we're going to get to today. It's pretty straightforward. In fact, it's really clean. It's got two APIs that are data plane. What we would refer to as sort of the work getting done in this protocol. The work getting done in this protocol is just two things. Encrypt something using an AES key, and in general, for our patterns at AWS, that something is going to be a data key. In fact, all of those 100+ services that I talked about, all that rattling off of all those names, those are all using the envelope pattern. And so when KMS creates a generate data key request, it's going to create a key, and then it's going to ask the XKS platform to envelope it. And then when something needs to be decrypted, KMS is going to see that this is an external key store, and it's going to ask your external key store to decrypt it. If your external key store does not respond, or is unavailable, or times out, KMS won't be able to decrypt that data. And that's kind of what I mean by kill switch. That's kind of what I mean by we're not caching anything in the middle. We must see the correct response from a decrypt call, or we are unable to, in the middle, process that request. There are some control planes that we used to essentially understand the keys we're talking to and to make sure that the system we are talking to is healthy. And so we built a health monitoring system. We're going to talk a little bit later on about monitoring. And we built a described key call so that we can understand what we're dealing with. I mentioned that notion of root. This is kind of a way to envision it with the data key enveloping pattern that I just spoke of. All of our services are going to use data keys to protect data. They're going to ask KMS to create that key and create the envelope for it. When using XKS, that envelope is ultimately going to get created through the XKS protocol from your keys in your clouds. So ultimately, you are the root, and you own the ability to open or create envelopes going forward. Now we're going to challenge that a little bit. When we create features at AWS, we have a great set of security engineers embedded in each team. We also have separately AWS Security, its own sort of military police, if you will, and you must bring your capabilities through their vetting in order to deliver new features. And AWS Security struggled with this one. because they know and understand KMS. They take a lot of dependency on KMS because all those services on the left-hand side are using KMS for over a decade today. And they look at this and they get concerned. Because if you take out the middle and you say, KMS is just a proxy now. We're going to proxy these requests and someone else is the root of trust. Security has to reason about all of that data on the left-hand side. That's formulas for soda drinks. That's telemetry for rockets. That's the next genome project. It's the most important information on the planet. And we're telling them, hey, all that data is now going to be protected and rooted in keys over there. And AWS security can't walk the halls. They can't see the ISO 27001 cert on the building. They can't understand the operator controls, the policy controls, the technology controls in that building. It's your building. AWS security ain't there. They don't understand the correctness of your key manager or the cryptographic strength of your key manager or the FIPS boundary of your key manager, and they can't ensure it. We can't be in your space, in your business, ensuring the correctness of that. And all of this traffic has to go over the public internet. And so they're like, how are we going to do this? This is a big risk. And we don't like to take security risks at AWS. And so they came back with a counter proposal, which is, what if we double encrypted this key? What if we create the key and we envelope it with a KMS key? And that's what I'll call the inner envelope. And if you stop right here, you're kind of sort of KMS today. KMS uses a FIPS boundary of FIPS 140 version 2, security level 2, quickly moving to security level 3 hardware. We are already in application for FIPS 140 version 3, security level 3. We filed that paperwork with NIST in September of this year. That means we passed the successful testing of that application with Acumen by September of this year. We'll be one of the first vendors, by the way, to have a fleet of HSMs at FIPS 140 version 3, security level 3. So that's the security AWS understands. But you're wondering, wait a second, KMS is doing too much here. Now KMS is the root again. But wait for it. We take that envelope, and we treat that as the request to XKS. So when I showed you that encrypt and decrypt flow, what we're sending out is ciphertext. And now we have some nice protections. Now we don't have to worry about secrets going out over the public internet. We don't have to be sending your encrypt payloads over the public internet. We are sending only ciphertext to begin with. But wait a second. Wasn't the goal here external control? Why is KMS in the middle of it? Look what we've done. We've kind of got the best of both worlds. We've got the same base level of security as any other KMS operation that's ever existed, backed and fleeted and protected by HSMs you know and love, and we can't open it. Because external to us is a new ciphertext envelope above us controlled by you. And so this is sort of a hybrid best of both worlds, I think. It gives you the control, the kill switch, the independence, the ownership of keys, and we don't have to reason about how strong was your FIPS boundary, or did operator controls disappoint you on a certain day, or did new TLS introduce things that are hard for us to reason about in the middle of this. And so this is the protocol. Then we talk about double encryption. It's a two-step process that involves an inner envelope and an outer envelope. Moving on, some fundamental things that stay the same, things that change. All the KMS symmetric APIs are identical. We don't have to change things for XKS. You'll even see the same ARN format, all of the sort of standard tooling you use for CloudFormation or how you set up IAM policies or how you run CloudTrail audits. All of that will be identical. All of that will be identical. It will have the same price as a standard KMS key, $1 per month. It will have the same price on the KMS APIs. So same pricing model as any other key. What's entirely new and different? And you take one thing away from today, it's how an envelope encryption pattern works. You take the second thing away, you own it. And let's talk about that. This is our sort of CAPS theorem. We can't give you an external key and say we take a full dependence on you and a total dependence on you. without taking a full dependence on you and a total dependence on you. So you have to be available. You have to be performant. You have to keep that key durable. You can't lose that key. If you lose that key, everything to the left in my diagrams, all of the data protected onto that key is rendered unreadable forever. And so you own essentially a new line in the shared responsibility model. You are taking on more responsibility because we can't have it both ways. We can't solve key issues when your key system breaks. Otherwise, we sort of break the first rule of Fight Club, which is it ain't our key. So we can't belabor that enough. This is shifting the responsibility model of what you have to do to achieve successful KMS. You do gain additional authorization, additional auditing, additional monitoring at the proxy and at the key management layer to see that this is up and operational. And you will have some different cost structures here. You will have to pay for, or look at open sourcing, the operating and licensing cost for the external key management of your choice. I mentioned that availability, and I mentioned that notion of monitoring. We're concerned about that too. We're very proudful of our availability. We were the first service last year to publish a 5.9s SLA in the data plane. Take it from me that if we're going to offer you 5.9s, I need to show the bean counters and powers that be that we run routinely at 6 and 7.9s of availability. 7.9s of availability means that we detect when we drop 1 in 10 million packets. In fact, to be at 5.9s of availability, we wake people up in the middle of the night when we drop more than 1 in 100,000 packets. So we are exceptionally tuning this service to have incredibly high availability because we have to. We are becoming the oxygen in the room. If you can't get data protection to decrypt something, you're going to struggle with Lambda, Kubernetes, S3, Secrets Manager, RDS, Aurora, Mongo, and everything else that took that dependency on data protection in the first place. So we've worked on our side to try to see what we can see as best we can into XKS. Remember, our termination is our VPC endpoint. That's the last thing we can see. But we built this monitoring interface, and if I don't eat up all of Vipul's time, he might be able to show it, to look at some of these capabilities. I'm almost done. We're almost ready for our demo. But I do want to put a shout out to the great vendor support we got for this. We wouldn't be here today without all of these vendors helping us get there. So I can't say it enough. And hopefully it's obvious to you. If we take a dependency on an outside system to do cryptographic operations for us, we need the correctness of that system and to work with us in our time frames. So we're exceptionally grateful and just super, super helpful support from all of these folks. Thales, Entrust, Atos, T-Systems. Some of these vendors are more in the systems integration side, and some of these vendors are building key management, and some of these vendors are essentially key managers. So there's a bit of a hybrid on this slide, but all of these vendors supremely helpful for us to get here. The other thing that I think is new and unique about XKS is that we're not hiding anything. This specification is public. You can read it. We posted it to GitHub. This specification has test tools. You can build your own. You can take our client test tools. This specification has a reference key manager interface. You can emulate what you're going to see from a vendor by using our container drop-in VPC-ready Rust proxy. And so we want to encourage testability, evaluation, feedback. We want to be as open as we can be and as transparent as we can be because this is about your control. It doesn't do us any good to tell you we're giving you a lot more control and not explain to you the protocol by which we do it by. I'm going to move a little bit quicker so that we can stay on time.
Okay. So I'm going to actually roll up my sleeves and hope for the best.
Good luck, buddy.
Yeah.
Good luck.
Okay, so let me set things up, what you'll see. So this is the general architecture that Jeremy talked about. Timer's going off. Okay. So on the left, you have anybody who's calling KMS, including AWS services. And you have AWS KMS shown in red. And in this case, we will be sending requests out to an external key manager. And the demo will be using the Thales Cipher Trust Manager. So what you'll see here is you'll see a bucket, an S3 bucket. In that S3 bucket, I will have an object. I will use a KMS key to protect that bucket. That's the KMS ID, a key ID that you'll see. And the key I'll be using will have this new key origin called the external key store origin. That's what tells KMS that the key material to do encrypt, decrypt resides outside in the external key manager. And since there is an external key, KMS needs to know the ID of the key in the external key manager. And the external key ID in this case will be that one here. So that's the general setup. If you want to remember something, just remember 38FC. We'll look for that key in the external key manager and make sure that things are working as expected. So this is the setup. And what you will see is I, as a user, trying to access an S3 object. So that will result in an S3 get object call. The S3 get object call will result in a KMS call because S3 realizes that this object is encrypted. And S3 only has the encrypted data key. It doesn't have the plain text data key to be able to decrypt that object. So it takes that encrypted data key, and it has to send it to KMS to get the plain text data key back. When the request comes to KMS, KMS realizes that this is an external key store key. And it looks up that external key ID, makes a call to the Thales CTM. And assuming all goes well, the Thales CTM responds in a time that doesn't cause KMS to time out. And you will get a successful response from the Thales CTM. This will allow KMS to be able to return the plain text data key to S3. And when S3 gets the plain text data key, it will use that plain text data key to decrypt the object and send the object back to the user. Okay? So we'll see that, hopefully, demo gods permitting. Now, let's say what happens if the key, for some reason, is unavailable. And there are many ways in which a key could become unavailable. The Thales CTM has a mechanism where you can block a key that makes the key unavailable. But you could also easily cut the power or cut the network to the external key manager. All of those cases and many more can cause a key to be unavailable. If that were to happen, you would see the same set of API requests going in. You will see the S3 get object, the KMS decrypt, the XKS decrypt. But this time around, things will not work. Things will fail. So if the key is blocked, the XKS proxy API specification says that the key manager will return an invalid state exception because the key is not in a valid state. That will cause KMS to throw back another exception, KMS invalid state exception, and that will cause S3 call to fail. So let's see how this works in practice. OK, good. OK, so this is me logged in. Hopefully, the font's big enough. If not, I can increase that a little bit. Is that better?
Sure.
Yeah. OK, so I'll go into the S3 console first. So here I'm logged into a demo account. And just to make things easier for you to see, I'll click on this bucket, and I'll hide this side panel. And let me remove that. So what you see here is an S3 bucket called reInvent 2022 XKS demo. And in this bucket, I have a single object. It's a PNG file. It happens to be a screenshot of the what's new announcement for XKS. And let's look at the properties of this S3 bucket. So there's a few things I want to point out here. One, encryption is enabled. It is using KMS for encryption. So SSE KMS, server-side encryption using KMS keys. This is the KMS key. So let's scoot over to the KMS console by clicking on this link and see what kind of key that is. So now I'm in the KMS console. This is the KMS key. The first thing I'd like to point out is the key yarn. Doesn't look any different compared to any other key yarn. This goes back to Jeremy's point that because this key looks and feels the same, it's very easy for any of the other services that integrate with KMS today to start making use of XKS keys. The other thing I want to point out is what you see in the cryptographic configuration. So this is a symmetric key. That's the most common key that other AWS services use. So in this version of the XKS proxy API spec, we do not currently support asymmetric keys because most AWS services are happy using a symmetric key for their operations. So this is symmetric key. This part is new. So we have a new key origin, external key store. This identifies this KMS key as being in an external key store. The other thing to keep in mind is that because it is an external key store key, it has to have a pointer to a key in the external key manager, and that's the pointer. So like I said, if you want to remember something, 38FC. Before we jump into the external key store, let's see where that is. So I'll click on this CKS ID, the custom key store ID, and which is in this URL here, in this tab here. So notice that we've had custom key stores before, but this is a new type of a custom key store. So previously, because we only had one type, we never really had a type explicitly. But now, if you were to go back and look at your AWS Cloud HSM key store, you will see that it has a key store type of AWS Cloud HSM. This one is an external key store type. Jeremy talked about 2 ways of connecting to the external key manager. This one is using a public endpoint. And what that means is that the external key manager is sitting at this URL. Yeah? And we will come back and talk about this monitoring section. But let's go over to that key manager and see what we have. So let's do this. So this was the URL I copied from the previous screen. And I'll hit enter, brings me to this page. This is the login page for the Thales CTM. So let me log in here. So far, so good. I go into my keys. Let's look at this one. Font size, OK. Let me increase that just a little bit. So the thing to keep in mind is this is the external key ID we talked about, the 38FC. So this is the key that is protecting my objects in S3. Okay? So if I do anything to make this key unavailable, my access in S3 will not work. So right now, the key is unblocked. So if I go back to the S3 bucket here, so let's go into the tab that has objects. And I'll select this object, and I'll say open.
Oh.
Voila. So my prayers worked. The demigod smiled on me. And this is the object that we were protecting in S3 with the KMS keys. So this one is the screenshot of the What's New announcement. Now let's see what happens if I go into the CipherTrust Manager and block this key. So I go into this actions, and I'll say block the key. And yes, I really want to block the key. And now let's go back and try that same thing again. OK, what happened? Let's take a closer look.
Sorry to interrupt. What I love is that you understood that's the best magic we can do.
Yeah. Yeah, so you can see that so KMS threw in KMS invalid state exception, but the exception tells you what went wrong. But KMS's ability to be able to tell you what went wrong depends on the key manager telling KMS what went wrong, especially if the error happened in the KMS key manager. So which is why if you look at the KMS XKS proxy API spec, you will see that there are many different error scenarios defined, and for each of those, we expect a specific message from the from the external key manager. So in this case, it clearly says that the external key associated with the KMS key is not enabled, and if you go back and enable it, things should work. So let's see if I really follow what the message says, does it work? So go back here.
Testing.
I come back, unblock the key. Key is unblocked. Let's try this again. And it works. Yeah? So this is essentially goes back to what Jeremy was talking about in the sense the external key manager is acting as a kill switch. Let's talk a little bit about the shared responsibility model and how that changes and what KMS is doing to help you deal with all the complexities. So this was the KMS console for the key, and this was the KMS console for the console page for the key store proxy, so for the external key store. So if you have played with AWS Cloud HSM-backed custom key stores, you will see parts of this page are very similar, but there is this part, the monitoring section, which is completely new. So if you look at the demo diagram we talked about, the setup diagram, there was the AWS data center, and then there was the corporate data center. And in between that, there is that clear line that divides what is customer responsibility and what is AWS responsibility. So if you've been an AWS customer, you've heard about the shared responsibility model, where AWS is responsible for the security of the cloud, and the customer is responsible for the security in the cloud. But in this case, what happens is that the part of the cloud, the one that's actually doing the cryptographic operations, is outside. And since AWS is responsible for the security of the cloud, but now part of it is outside, that's why we introduced double encryption. Because we are still responsible for the security of the cloud as a whole, so even if there is part of the encryption happening outside, we want to be owning the security of the cloud. Now, AWS goes to great lengths to make sure that the services are highly available, highly performant, and we have lots of tools that allow our operators to be able to do that, to be able to monitor the health of the service, to be able to set alarms and get notified as soon as something starts to go south. And in this case, we are relying on the customer to be able to provide the same level of availability, key durability, and performance. So we thought, why not give our customers some of the same tools that we have internally? So this is our first attempt at providing a set of tools that the customers can use to make sure that their external key manager performs well, is highly available, and if there are any errors, it can highlight them. So what we do is we monitor each and every request going out of KMS to the external key manager. We monitor the responses coming back, and we log it all into the customer's CloudWatch account. And we give you the ability to create alarms on those metrics. And here are some of how we display some of those metrics. So here you can see I have a total request metric. Let me actually go into here and show you what's happening. So this is just a 3-hour window. If I expand it to a 12-hour window and use the 1 minute. So this is what's happening. I've been running a load of about 30 TPS, not too high, onto this external key manager for a while. I think I'm still a little jet lagged, I guess. I don't know why, though, but I was up at 4. So this thing's been running around since 4 a.m. At about 30 TPS. If you zoom in here, you will see a little bit of an up and down, and I think that becomes more clear if you go back to that three-hour view. And that's because over that constant TPS, there's some get health status calls. So that's one of the APIs that Jeremy talked about, where we are sending out get health requests messages, monitoring them. And because those messages go out once every 5 minutes or so with a slight jitter, that's why if I switch to this 5-minute window, you will see that either I have the baseline or I have 2 more than the baseline because of that slight jitter. We are sending out once every 5 minutes or so. So this is one thing. So what do you want to monitor here? Because we have a TPS limit on the KMS side of 1,800 requests per second on a per custom key store, if you try to get to that, if you're getting close to that, you want to set alarms for yourself. And even before you get to the KMS limit, it's possible that your external key manager has a lower limit, and you want to be able to set alarms on that. This is kind of like the availability metric. So if you see any dips here, it means that your key manager is not healthy. And then you can look at this graph to see what kinds of exceptions you're getting. So prior to this meeting, I was playing around with making sure that the demo was working. So when I disable the key, you can see that that caused the external key manager to send a whole bunch of invalid key state exceptions. On the left-hand side here, we are monitoring the latency. Because KMS maintains a timeout, KMS will allocate at most 250 milliseconds for the response to come back. So here you can see what's happening. So most of the encrypt, decrypt calls are under 30 seconds. So Jeremy talked about how we require the external key manager to be within 35 milliseconds ping latency. That's our guidance. But in this case, you can see that the proxy is doing much better. Not only is the ping latency under 35, but this latency includes all the time to actually do the encrypt and the decrypt on the external key manager. So those are some of the tools, and as we learn more, we will be adding more tools to help customers make sure that their external key is highly available and performant. So with that, I'll turn it back to Jeremy.
Can you press the HDMI
Yeah, sure.
one? That was awesome.
Yeah.
All right. We're almost done. So we talked about kill switch. Just want to be clear that in some of our services, there are some caches. EBS and DynamoDB and SQS has a configurable cache. S3 has a new ability to cache keys using a feature called bucket keys, which serve as an intermediate key that S3 creates with KMS and then creates its own KDFs to generate object keys underneath it. Huge, important optimization for large data protection workloads in S3. I super encourage you to look at bucket keys, whether you look at XKS or not. But in these places, KMS is kind of in the middle, right? Phone call comes in, hey, give us a decrypt. Hey, XKS, give us a decrypt. We decrypt it back, we give them back the data key. The cache will determine the full timeout sort of cycling of these services. So sometimes we get asked, how fast will things go dark in the cloud? And the answer is, it depends. And so you'll need to look to your data protection patterns in all of your services and some of your cache configurations to get the full extent of that kill switch timeout. One thing that also is worth noting, the entire scope of the external key manager is outside of our technical and operational control. Again, first rule of Fight Club, not our key. Therefore, the availability of external key managers, really of all KMS operations on these keys, and implicitly all services that are pointing at external keys, are all outside the scope of our SLA. We could not be held to an SLA if the customer disables key material or access to keys in their data center and it wedges us, because that is on the customer side of what's happening. And so we will specifically be excluding XKS from our SLA and availability statements involving both KMS and every integrated service of KMS that uses SSE KMS or data protection patterns with KMS pointing at external keys. I want to end with a couple sort of thoughts on, is this right for me? Is XKS right for me? I think you should think of it as the end of the spectrum. On the far left-hand side of the spectrum is tens or hundreds or thousands of HSMs in a region operating at very, very high levels of availability, operating at a P50 of 3 milliseconds and a P90 of 9 milliseconds and a P99 of 11 milliseconds in a decrypt path. People get promoted in KMS by shaving 1/10 of a millisecond off of our latencies. So we are incredibly obsessed with improving the performance, improving the availability, improving the latency, and holding that key under the highest security bar. We believe these keys are kept in the highest security bar. That's the left-hand side. As we move through, some customers want more control. And that's really why we're here today, is because different customers have different risk profiles and different compliance mandates and different interpretations of the same mandates. So some customers will read that different levels of control are suitable to meet those compliance mandates. And so we've got some customers using an imported key methodology where they create the key, they own the key, they give us the key as a lease. Some of our customers lease us keys in a very short-term manner. I would encourage you to think about that pattern. It's an interesting pattern for control because you own the key, you rent it to us, but it becomes a KMS key from the purposes of those HSMs. The performance, the latency, the availability are KMS properties of imported keys. Some customers prefer the isolation, independence, and ownership of a dedicated single-tenant HSM. And that's why we launched Cloud HSM 4 years ago. That's the custom key store. That's the first reason we launched it. And that's sort of the middle ground here. That gives you the ability to have a close-by HSM with AWS operator understandings of the network properties and other properties of that system, but your operation of the data plane of that system. And you'll notice that we're getting a little bit out into the frontier now. External key stores are out in the frontier. They are the greater customer control, but this slide's not unintentional. You are moving away from some of the performance, availability, and latency characteristics of the left-hand side. And so really, that's really it. XKS could look attractive to a lot of use cases, but we would recommend that you scope it down. And you scope it down around, you have very strict regulatory workloads that mandate possession of keys in systems outside of AWS. We're not going to tell you, no one at AWS is going to tell you how to interpret and how your compliance mandates impact how you choose to implement data protection. Your businesses and your verticals and your regions and your DPAs are too specific to you for us to be able to tell you how to interpret them. But we would encourage you to look at all the other paths first, including there are customers using standard KMS keys where AWS generates and stores the key for you. Notice we call that a customer managed key. Notice the customer retains the only access to that key. It is a key created in their account and only they can make use of it. And so that can be a suitable way to interpret control existing with the customer. I also want to point out the space is changing. It will ebb and flow over time. We will see different geopolitical agreements come and go. For those old enough to remember, in the late 90s, there was Safe Harbor 1, and in the mid-2010s, there was Safe Harbor 2, and there was Data Shield, and all of these different initiatives between governments to try to sort this out. Recently, in October, some of you may have noticed that Joe Biden signed an executive order trying to clarify and establish new working relationships with the EU for how to think about data exchanges. So this is a particular part of the compliance world that is in some level of flux. So you have to map that and maybe have a strategy that can shift as those tides go up and down. And lastly, I would look at limiting the keys to the least amount of data required by your regulators. Again, that atomicity of when to use a key is going to be helpful to you. Because as we think about, we profile some very large workloads in KMS. Some of our customers generate 60,000 TPS. It will be practically quite hard to profile 60,000 TPS through the external key store. And with that, I think we're just about out of time. We're going to leave you with some breadcrumbs to where to go next. First and foremost, we have a spectacular documents team. Our documentation team is bar none rock stars. And so you want to get a clear, very descriptive, accurate understanding of XKS. The very first place you should start is in our developer guide. You'll also need some other scaffolding along the way. If you're going to connect out into the world, you're going to need to understand VPC connectivity options. You're going to want to think about private link. You're going to want to think about AWS Direct Connect. And so you've got some different AWS tooling to think about how to build those load balancers, those VPNs, those constructs that you'll need to talk to external keys. And not on this slide, but probably obvious, you'll need to contact an external key store vendor or a partner. Atos and T-Systems are there working to help you if you don't want to take that on yourself. And the number of key manager vendors I've already been talking about, Thales, Entrust, HashiCorp, and Fortanix, are ready to help guide you in terms of how to build XKS into their products. And with that, we are out of time. Thank you very much for finding us in your Easter egg discovery of our session.